Hi students, it's Stephanie. At the end of class today we talked about law of signs and the ambiguous case. And I'm hoping I had time in class to show you the proof of law of signs. Either way, I'm going to show it for the first time or again. Never hurts. Let's just say you have a much better looking triangle than that. A non-right triangle, an oblique triangle. And we're going to label this A, B, C. We're going to go ahead and drop down an altitude in the triangle, which is going to cut this into two pieces. And we're going to name this whole side B, since it's across from angle B, this whole side A, and this whole side C. We'll label this guy H for the height of the triangle. Now I'm going to look just in, let's give us another color, this triangle right here. And if I'm standing at this angle, I can get sine of C is opposite, which is H, over hypotenuse, which is that A. And let's go ahead. I could also do in this triangle, the non-shaded triangle, sine of A is equal to opposite over hypotenuse. Well, we see that we have H in both of these equations. So I'm going to solve for H in both of them. So just focusing on this equation, I would multiply both sides by A, and I get H. And we'll use another color. In this equation, I'd multiply both sides by C. Excuse me, still fighting that cold. So, by the transitive property, if these both equal H, we can set them equal to each other. And the last little piece I'm going to do just to make it look a little nicer is I'm going to divide both sides by A. Well, those will reduce out. And I'm going to divide both sides by C, which is the same thing as multiplying by 1 over C. So we end up getting one of our equations for law of signs. If we wanted to get the B ratio, we would just drop the altitude down from A, or even C. But we can't use B in this since we cut it. And so there's the proof. So now we're going to talk about, well, here's the equation that we just went over, and we see where it's derived from. Now this piece here, it's saying when to use law of signs, and the last thing I want you to do is to memorize. Okay, so our text gives us cases of when we can use law of signs, which is angle, side, so angle, side, angle. So it has to look like that, where your side is included between the two angles. Or side, angle, angle. Or the last one is this ambiguous case, and that's what we went over at the end of class, and that is side, 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 angle. Any of these cases you can use law of signs. Now, you're not going to memorize them, because law of signs is going to be your default that you use in any oblique triangle. If you have a full ratio, either you have both angle C and side length C, or both angle B and side length B, or both angle A and side length A, then you're going to use law of signs. And so to solve for one of these, let's go ahead, change our pen to blue. I like to give myself a diagram like what we talked about in class. This blue is very light. A, B, C. Doesn't matter how you label it, but my A is 39 My B is 75. And my A is 3. So you can see you have a full ratio because you have two A's. So you know you can use law of sines. So it's going to be sine. So it'd be sine of 39 degrees over 3. You could have done it any ratio. You could have done 3 over sine of 39 degrees if you'd like. And then I have my B, which is sine of 75 degrees. But I don't know my little b. And so how do you solve ratios? Well, we want to go ahead and proportions, I should say, and it's going to be cross multiplying. So it's going to be b times sine of 39 equals 3 times sine of 75 divide by sine of 39. And I'll end up getting, using my calculator, that will reduce out, I end up getting about 4.6. We'll round to the tenths. Now, there was something really easy I could have solved off the bat without using law of sines, and that is to find angle C. Because I have these two angles, and I know a triangle has to add up to 180. So C is 180. Take away these two angles. So we end up getting 66 degrees. It is important to use the degrees, so get in the habit of that. We'll learn something else besides degrees soon enough. And so it's nice to always use the appropriate unit of measure. So there's one last thing we have to solve for, because remember, solving the triangle says solve for all the unknowns. So the last little guy we have to solve for is little c. So I'm getting a little messy. I'm getting used to using this guy. So now I'm always going to use the full ratio that was given to me. So I don't, by accident, use something I messed up that I found earlier. And now I know sine of 66 over little c. And simply to save room, unfortunately I'm running out of space, it's going to be c equals 3 times sine of 66 all over sine of 39 degrees. So I get about 4.4. Excuse me, so sorry. So you'll see you're done with the triangle. Now, you can be my guest and leave it like this, or you could get really nice and go ahead and make a list on the side. If you really want, you can box your answers. The one thing is, I don't want it to look like chicken scratch, and then all of a sudden I have to find these boxes. Your work should lead me to the answer. It's really important in mathematics. Okay, so let's go ahead and last one. This was not the ambiguous case because this was angle, angle, side. So for another one. So here we go. Again, I like to have a triangle to go off of. Doesn't matter how you draw it. This is 35, 17, 3. So once again, I could solve for this angle, which I didn't do for the first time, or the first thing I solved for in the last problem. But let's go ahead and do it here. So C is 180. Take away the two angles we have. And so we end up getting 128. So set up your proportions. Sine of 35 degrees over little a equals sine of 17 degrees over little b equals sine of 128 degrees over 3. So there's my full ratio. So I know I can use law of sines. So I'll go ahead, doesn't matter which one you want to solve for first. I'll do sine of 128 degrees over 3. I'll solve for A first. And just again to save time, doing cross multiplying, I end up getting 2.18. And then when I focus on this ratio here, cross multiplying, I'll end up getting 1.11. And I guess I should be consistent because I did say to the tenths. And there you go, you've solved for all of them. One thing I should mention is, what kind of triangle, is this the ambiguous case? Well, no, because it's angle, side, angle, right? And then even though, don't have to worry about that. Described back here, but we went over this in class, so that's why I bypassed it. Ambiguous case issue. Now here, we have to figure out how many triangles there are. And what we're going to do in this video is we're just going to leave it there, and then we're going to solve these in class. So let's see. Could this be the ambiguous case? Well, my brain says, yeah, sure. I see two sides at an angle. Make sure, though, it's the ambiguous case. So we talked about a shortcut, but just in case. So here's just my random triangle. They give me side length B, they give me side length C, and then they give me angle A. Well, that is the ambiguous case. So that means my options are 0 or 2 or 1 triangle. And so, and this is all, well, we're going to set it up. Sine of 95 degrees over 4 equals sine of C over 5. Does that make sense so far? So now if I go ahead and do my work, 5 times sine of 95 equals 4 times sine of C. Divide by 4. No, don't write as big as me. Give yourself more space because we'll be working on this more in class. So these reduce out. So now I have sine of C equals 5 times sine of 95 over 4. Remember, when we want to find an angle, we have to do the inverse. So that's why C will equal the inverse of this beautiful, let's see if I can fit it, ratio. So when you do that in your calculator, it becomes an error. So what that tells you is there's 0 triangles. So you don't have to solve, even though we kind of had to do partly. And so what I want you to do for the rest of these notes, you have this page to come to class with just telling me how many triangles, and this page. So I want you have for these next 3 problems. Okay. Bye. See you next time. These we're going to do in class, and we're going to solve the rest.